I'm Graham Ward. I'm the science advisor to this particular project. I'm at our core research site at Allenford in southwest Victoria. At this core site we have an irrigated site and a dryland site. Now, with this particular research work, we're looking at the nitrogen use efficiency of nitrogen fertiliser applied to perennial dairy pastures in Victoria. We have a range of treatments on this site which include a range of rates of application of nitrogen fertiliser applied after grazing. We graze at the 3-leaf interval and then reapply. Our aim is to improve the efficiency of nitrogen use across the whole year by understanding what responses we do get, the contribution of nitrogen from the soil reserves, and what nitrogen use efficiency we do achieve. Another piece of research that we're doing on this particular trial site is a series of intact soil cores that we've collected from a range of different dairy soils from across the region, and we're applying 15N labelled urea fertiliser that when we apply to the plants growing in the cores, we can determine the fate of that applied fertiliser. How much is absorbed by the plant in herbage growth, how much is accumulated in the soil, and how much is lost from the system that way. So that way we can get an accurate figure or representation as to where does our applied nitrogen go, how much is from the fertiliser, how much is from the soil reserves, and come up with a budget as to the fate of the nitrogen that we do apply. One of the lost pathways of nitrogen from applied nitrogen fertiliser is as nitrous oxide gas. Although this is relatively small, we're interested in it because it is a potent greenhouse gas. We use gas chambers such as this to measure emissions across the year from the time we put nitrogen fertiliser on until the next harvest. We're at our satellite site, which is at Coorimundle near Timboon in southwest Victoria. The reason we've got a satellite site is that one of the major findings of the work on our main site has shown that our responses to nitrogen fertiliser in the autumn is lower than anticipated. So we want to test that out on a range of different soil types and environments. On this site, we'll be applying 5 different rates of nitrogen fertiliser a few weeks after the autumn break and measuring the pasture yield responses and the soil mineral content. Our earlier work on the main site has shown that we have got the potential to delay the application of our first rate of nitrogen fertiliser, and this is leading to improvements in efficiency because we're still growing as much pasture but delaying and potentially reducing the rate of nitrogen fertiliser that we use in the autumn here.